In our first optimization problem, we want to find the dimensions of the lightest open top circular cylinder that will hold a volume of 1,000 cubic centimeters. So begin by writing the secondary equation, which will be a volume equation. And volume will be pi r squared h. And we're told that the volume is 1,000 cubic centimeters. Okay, next we want to come up with the lightest possible container. Needing the lightest, we're going to minimize surface area. So we're assuming that the thickness of the cylinder is all exactly the same and that the weight of the metal is the same. So surface area, we'll area the sides first. So we know area the sides be circumference times the height plus the area of the bottom, pi r squared. Again, since this situation is with the open top, we only have 1 pi r squared. Okay, next we know we have to write the surface area equation. That's what we're trying to minimize in terms of one variable. So surface area is equal to 2 pi r. Go back to my secondary equation. Solve for h by dividing by both sides by pi r squared. Before I find my critical points to take the derivative, I'm going to reduce and simplify as much as I can. So pi divided by pi, r over r squared reduces. And we can simplify the top. 2,000 over r plus pi r squared. Now we have our surface area equation expressed in terms of one variable. We'll take its derivative. So moving this r to the top becomes r to the -1, and we'll do power rule. So negative 2,000, r to the -2, plus 2 pi r. We'll set it equal to 0. And then at this point, we have a choice here. We'll have our calculator on this. We can either graph this and look for where it crosses the x-axis, or do a little bit of algebra and solve it out. I'll do a little bit of algebra here. So we need a common denominator. Now I'm going to solve for the numerator. So 0 equals negative 2,000 plus 2 pi r cubed. So I'm going to add 2,000 and divide by 2 pi. I'm taking this out 3 decimal places. We have 318.310. And then we're going to take the cube root. And I'm finding the radius to be 6.828. That is in centimeters. Now, I wanted the dimensions of a cylinder would also include the height. So since we do have a radius, let's go back to our secondary equation and plug in the radius and find the height. So the radius was 6.828. So we have 1,000 divided by pi times 6.828. And I have a height of 6.828 as well.